All right, you guys, we have been talking about light and done a lot of calculations. So we're going to take a break from that and we're going to actually move on to something else. We're going to look at the electrons and what's going on with them in the atoms. So right now you probably, or you should at least have a basic understanding that we have a nucleus and then we have electrons that are outside of that nucleus in different, what we call levels. So these levels are going to be I'm going to start calling them quantum levels. And sometimes they are called principal energy levels. So I'm going to be sending you these notes. So I would strongly recommend that you print them and kind of work them with me. And I apologize. I'm trying to find some way to print this or shoot this video to where it doesn't have a shadow, but I have not found a way yet with anything that I have at my house. Or anywhere in my house. So I'm trying the best I can with the equipment that I have. So I hope that you guys are able to see this okay. So we've got these different levels. We've got level 1, level 2, level 3. Those electrons, remember, are just kind of floating outside of, think of them as floating outside of the nucleus. So we're not really concerned about the nucleus right now. We're really going to focus in on what's going on within those levels. So within those levels, we are going to have stuff called sublevels. And some of you guys may have remembered this from physical science. So sublevels are going to be like an s orbital, a p orbital, a d orbital, and an f orbital. And I apologize, my dogs are going crazy upstairs. So we're going to be looking at what's going on with those atomic orbitals and where those electrons are at for certain elements. So on the next slide, if you kind of work with me in your notes, so we have s, p, d, and f. So an s orbital is made up of, or a S sublevel is really what you want to think of it as. S sublevel only has one orbital. So I'm going to draw it as one line. And that one line, that one orbital, can actually have 2 electrons in it. So my arrows are representing electrons right in there. So an S orbital can only have 2 electrons. A P sublevel is actually made up of 3 different orbitals. And again, each orbital can hold 2 electrons. So there would be 2 in this one, 2 in this one, 2 in this one, for a total of 6 in a P sublevel. Now a D sublevel can actually have 5. So in each one of these lines that I draw as an orbital, that can always have 2 electrons in it. So in a D orbital, there can be a maximum of 10 electrons. So for each element, it's going to be different. I'm just giving you the maximum amount right now. And then an F orbital is actually made up of 7 orbitals. So 1, 2, 3, 4, 5, 6, 7. And again, each orbital could have 2 electrons in it. So an F orbital, if we get to it, which we will not today, could actually have 14 electrons in it. Okay, so what we're going to look at next is the next page. So here's kind of the diagram that I attempted to draw. You've got orbit 1, meaning level 1. So remember that level 1, it can have just a 1s orbital. So I'm going to kind of show it like that. And then the 2s, or the level 2, can have a 2s orbital, and it can also have a 2p orbital. And then 3s, or level 3, can have a 3s. It can also have a 3p, but it can also have a 3d, which had 5. So if you kind of look at those orbitals, like if you look at 1s, well, it has 1 orbital, so that level 1 can have a total of 2 electrons in it. And then when you move to level 2, well, there's an s orbital that can have 2 electrons, and there's a p orbital, which can have 6. So 6 plus 2, level 2 can have 8 electrons. This probably looks familiar to a lot of you guys because we did have you work on this in physical science. Level 3, there's an S, there's a P, and there's a D. So there's going to be 2 plus 6 plus 10. So level 3 can have 18 electrons. And if we moved on to level 4 can actually have an S, a P, a D, and an F. And if you add that together, it's going to be 32. So that's what you guys learned in physical science. We didn't really look in depth like we're going to take in a few minutes and kind of look at how many total or how many are in each different orbital. So that's what we're going to move on to here. So this diagram or this figure table kind of explains what I've talked about, the different number of sublevels and what's going on in each one of those rings. But I think that picture probably describes it a lot better. Okay, so let's move on to the next page. I may cut this video in half if it becomes too long. But again, I just went through this too. Level 1 can have 2. Level 2, because there's an s orbital. This one has an s and a p. This one has an s, a p, and a d. And then this one has an s, p, d, and an f. So that's big picture, like how many electrons can be in those levels. But what I want you to learn this year, in which some of you guys did in the honors class, but we're going to go a little bit more in depth with it this year. What I'm going to teach you guys to do with these 3 rules. So we've got the Aufbau principle, the Pauli exclusion principle, and then Hund's rule. This is how you're going to learn to write an electron configuration. But I'm going to kind of teach you these rules as we go through and we work through them. So big picture here, what I want you to get out of this is you're going to have to be able to draw something called an orbital diagram. And again, I'm going to go through this stuff. I'm going to work through several of them with you. Number 2, you're going to be able to write an electron configuration, which sometimes you will hear people, even me, I will call this short form. And then you're going to be able to look at that electron configuration and tell me how many unpaired electrons there are. And you're also going to be able to tell me how many valence electrons there are. So that's kind of what we're going to do in the next part of the video. So we're just going to start working these, and these are the 4 things that you should be able to do for any element that I give you. So we're going to kind of work through this together. So I'm going to start with the very first one. So Aufbau principle, this is, according to this principle, electrons occupy the lowest energy level first. So that means it's going to work towards, from the nucleus outward. The ones that are closest to the nucleus, meaning the 1s orbital, is going to be lowest energy, and it's going to work its way outward to higher levels. So what I mean is it's going to start in the center and work its way out. Okay, so the first level that's filled, we're going to do hydrogen. So if you need to grab a periodic table to actually know how many electrons, I will kind of tell you in this video, but you should be able to look at the element on the periodic table and determine how many electrons it has. So the atomic number for hydrogen is 1. That means it has 1 electron. Well, by this rule, it's going to fill the lowest energy level first. So the orbital diagram that I talked about earlier would be 1 electron. So you'd show 1 up arrow. So that's the orbital diagram. If you wanted to write what I call the electron configuration, or the short form, you just write it like this. You give me the level and the sublevel, and then you put a superscript to tell me how many electrons are in there. Now, if you wanted to tell me how many were unpaired, well, this isn't paired with 1. So unpaired, there's 1 unpaired electron. Valence, well, that's the only electron it has. So it is also the number of valence electrons that it has. So that will get a little bit easier to look at because we only do have 1 electron at this point. So if I moved on, I'm going to do 2 more right here. I'm going to do helium, which is atomic number 2, meaning it has 2 electrons that I need to place in the levels. So again, by this rule, lowest energy level is first. 1s has to be filled, and then it would move on. Well, remember the 1s, the s orbitals anywhere can hold 2 electrons. So I'm going to have those 2 electrons there. So that's the orbital diagram. And then the short form, or the electron configuration, the 1s orbital has 2 electrons in it. So I'm going to show a superscript of 2. Unpaired for this one, well, when they're up and down like that, that means they're paired up. So I actually have 0 unpaired on this one. Now valence, those are the 2 valence. There's 2 valence electrons for that one. All right, next one I'm going to practice with is lithium. Lithium's number 3 on the periodic table. So I've got to figure out where they're going to go. So again, if you kind of look at this diagram, it's going to fill 1s, and then it moves to 2s, and then it goes to 2p, then 3s, and you can kind of work your way up. That's how it kind of gets filled. But in this case, 1s, remember an s orbital can only have 2 electrons. But I'm not done because this element actually has 3 electrons. Every electron configuration for every single element would be different. And I just kind of have to follow the same rule to kind of place them in these levels. So after 1s is filled, I've got to go to 2s. And in this case, I only have 1 more electron to place because I already had 2. So there's my 3rd electron. So That is the orbital diagram. The short form, or the electron configuration, well, the 1s orbital has 2 electrons in it. The 2s orbital has 1 electron in it. So that's the orbital diagram. This is the electron configuration, or short form. And then you also have to be able to tell me how many unpaired, how many valence. So for unpaired, I've got, this one is the only one. Those two are paired up. That's my unpaired electron. Valence. Valence, the definition of a valence electron is the electrons that are in the highest or the outermost energy level. Well, this is level 1, meaning that would be ring 1. These are in ring 2. This is the outer ring. So there's 1 valence in this case. So 1 valence electron for lithium. All right, so the next rule, Pauli exclusion, says, according to this principle, the atomic orbital can only hold 2 electrons, which I've been showing that. Once you put 2 in there, you have to move on. And they have to be opposite spins. Well, that's why I've been putting an up and a down arrow. That's how I'm showing the opposite spins. So this rule, we were kind of doing this rule as we were doing those. But I'm going to do 2 more here. I'm going to do beryllium first. So beryllium is actually number 4 on the periodic table, meaning it has 4 electrons. So I've got to fill the 1s first. Again, we have to follow both these rules together at this point. So lowest energy gets filled first. I can only put 2 electrons in an orbital, and I have to show them with opposite spins. So I'm kind of following both of these rules as I'm doing this. But I've got to place 4 electrons. So then I've got to move on to the 2s orbital. That's going to be an up and a down arrow. There's my 1, 2, 3, 4, my 4 electrons. So that's the orbital diagram for beryllium. The short form for beryllium would be 1s has 2 electrons. The 2s has 2 electrons. Then I've also got to be able to say how many unpaired and how many valence. Well, when I look at this, those 2 are paired up, those 2 are paired up. There's no unpaired electrons in this element. And that can happen. There can be unpaired, or there aren't any. You're always going to have an answer for valence, and it's always going to be a number between 1 and 8, just to kind of know that. You guys know valence electrons, but when you're looking at this. So again, level 1 is not my highest level. Level 2 is my highest level. And I have those electrons in a 2s orbital. So those right there are my valence electrons. There are 2. So the next one I'm going to do, this will kind of explain what you may have to do in some cases. So I'm going to move to boron. This is my next electron. I got to add 1 more electron beyond beryllium. So again, my 1s is going to be filled. That's 2 electrons. 2s is going to be filled. That's 4 electrons. So if you look up here at this diagram, if 1s gets filled, 2s gets filled, 2p is the next orbital. Now 2p, remember, it has 3 different orbitals that make it up. So I need to draw those 3 lines. So this is a 2p. But I have only got to place 1 electron because I've got 1, 2, 3, 4 electrons in there, and I only need 5. So I'm only going to put 1 electron in there. Okay, so my short form, that's my orbital diagram. Orbital diagram, if I ask for orbital diagram, I'm asking you to draw the arrows. 1s has 2 electrons. 2s has 2 electrons. And then 2p, only 1. So these numbers should always add up to the number of electrons that you're placing in there. So then unpaired and valence. So this one, unpaired, these are paired, these are paired. This is the only one that's unpaired. So 1 unpaired. Now valence. Valence can be tricky here. I've got electrons in level 1, but I've also got electrons in level 2. So if I've got electrons in the same level in 2 different orbitals, I've got to add them together. So this has 1, 2, 3 valence electrons. Now, if you look at the column that boron's in, it's in group 13. So you should be able to look and say, well, that 13 means there's 3 valence. Well, there they are right there. You've got to add the s and the p orbitals together to get those valence. All right, one more rule, and then I'm going to stop the video, and we'll make another video where we're doing some practice. So last rule is actually Hund's rule. So Hund's rule is really just that electrons are going to, it's kind of confusing. Electrons are going to occupy orbitals of the same energy that makes the number of electrons with the same spin direction as large as possible. To clarify that, you're looking for placing it to where you have the maximum number of unpaired electrons. And I'm going to show you how you do that. I'm going to write E- for unpaired electrons. Okay, I'm going to kind of show you how you would do that in 2 cases. So if you have nitrogen, let's move on to nitrogen. So nitrogen has seven electrons. So again, I got to follow all the other rules. So 1s is filled first. That would be 2. And then 2s would have 2. So it doesn't matter what level it's in. An s orbital always has one line. But then I get to 2p. 2p, actually I've got 4 electrons, so I need 3 more electrons placed in there. So to get my maximum number of unpaired electrons, what I have to do is I can't pair them up. What I have to do is place 1 in each one first before I start pairing them. So I'm going to count. This would be 5. This would be 6. This would be 7. And then if I had more, I would come back and pair them up. But you get the maximum number of unpaired electrons this way. So this is the electron configuration for nitrogen. So short form would be, electron configuration or short form is 1s2, 2s2, and then 2p3. So that adds up to 7. Unpaired, again, because I put 1 in each one, those 3 are my unpaired. Valence would be, again, I have to add everything in level 2 because that's my outermost energy level, not just sub-level. So I've got to add those 2 with these 3. It has 5 valence electrons. All right, then oxygen. So oxygen is number 8. So I've got an s orbital, that would have 2. I've got a 2s orbital, that's going to have 2. And then I need to move to 2p. And I've got to count 5, 6, 7. Then I'm going to come back and start pairing them. If you didn't do that, you would have 0 unpaired because you'd pair these and pair those 2. And you wouldn't be getting the maximum number of unpaired. So there's the orbital diagram. It's 1s2, 2s2, and then 2p4. So again, unpaired, those 2 are the unpaired ones. Valence, highest outermost energy level. So level 2 again, but there's an s orbital and a p orbital that I have to add together. So I've got 4 here and 2 here, so 6. And if you look at the column that oxygen is in, it's in group 16, it should have 6 valence. So this next little diagram kind of gives you the electron configurations for the first 11 elements, I think. So, and then I just kind of want to quickly, before we actually start practicing, kind of show you, like this is the order that it actually goes. It is important to understand that it fills the lowest energy level first. And it's kind of weird if you look, it goes, this is the order that it actually goes in, 1s, 2s, 2p, 3s, 3p, but then 3d is not filled next. It actually fills 4s and then comes back down to 3d. It's because 4s has lower energy than 3d. So it's going to kind of work that way. It's going to fill the lowest energy level first. But there's a really easy trick to this. If you can zoom in on this or pause my video and kind of look at this, if you just read the periodic table like you would read a book, it tells you the order. So first up is 1s, then 2s gets filled, and then 2p, and then 3s, and then come over here to 3p, and then 4s, but after that is 3d, then 4p. So and then 5s, and then 4d, and then 5p. And as you go down, we're not going to work with any harder ones here, but after 6s, before it goes to 5d, it actually comes down here and fills 4f. And then same thing on 7s. It comes down here and it fills 5f, and then it goes back up to 6d. We will be working with some harder ones. I'm not going to focus on those right now, but that's just kind of how you read this level or this periodic table to kind of figure out how to solve that. So that's all I have for this video. What I'm going to do is I'm going to finish the notes with a different video and we can kind of work through problems. If you feel like you're comfortable with this, you may not need the other video, but you might. So I'm going to go ahead and make it anyway. So hopefully this helps you and you're able to see everything. Please give me feedback if you're not able to read what I'm writing or can't follow what I'm doing. Please let me know in that Google form on the feedback form. Thanks.